Continuing this problem from the previous video, we have the partial fraction decomposition for our transformed function y of s. So to do some algebra, we determine a, b, c, d, and e. So what happens is big y of s, which we have to invert, filling in for a, b, c, d, and e, we end up with this expression. Now, there's a little bit of work for us to do on this last term. Notice that what we had to do was complete the square. S squared plus 2s plus 2, we're going to rewrite that as s plus 1, the quantity squared, plus 1. So what I need is for this s to be in terms of s plus 1. So rewrite s as s plus 1, and when you do that, we're actually adding a 3/2. So what ends up happening is this 2 turns into a 1/2, because if you were to distribute this 3/2, we get back the original expression. So now we're able to invert. We know how to invert all of these. So inverting term by term, using the linearity property of the inverse transform, we end up with our result. Y of t is equal to negative 3/2 plus t plus 1/2 t squared plus 3/2 e to the negative t cosine t plus 1/2 sine t e to the negative t. Notice that we recognize this inverse transform as being in terms of cosine and sine, but we also have a shifting property because in place of s, we have s plus 1. That's where the e to the negative t comes from.